Okay, so we're going to continue with the analysis, the properties of Gale-Nikaido mapping. So again, this is the first property. So if I am at the equilibrium price vector, obviously there should not be an update. Okay, so the updated price phi of pi star should be equal to p star. Okay, so the second property was, if you remember, the sum of updated prices must be equal to 1, right? Because we define phi of pi in S, okay? Remember, unit simplex. So unit simplex requires that property. So updated prices must be summing to 1, okay? So how do we prove that? Well, we have the formula. Let's start with there. Pi maximum of zeta I p 0 divided by 1 plus summation over j 1 to n maximum of zeta j p 0. Now, careful. I'm looking at the updating for commodity I, but here I also have the entire excess demand functions there. Okay? By indexing J. So these indexes are important. They both index the commodities. Okay? 1, n, but for different purposes. Okay? Now, let me write it in this way. Times j1 to n max zeta j p0. Okay, this must be equal to pi max zeta I p0. So the same equation, right? Then I want to sum all over again for I, okay? So careful. I'm summing over I now, okay? I'm summing over I. There is this j term here. Be careful with that. Zero. Then I have sum of prices plus the sum of, again, with respect to I have max zeta I p0. Okay? Now, here we have a couple of things to realize. First, realize that this is equal to 1 by definition. Okay? This is equal to 1 by definition. Now, you should also realize that this element here, this, okay, this does not depend on I, right? So this can basically go out. You see? This can basically go out. So let me clear some space for myself. Okay. It's a bit slow. Okay, Now, what's happening? I have phi p, okay, plus, then let's denote this by A, okay? So A goes out, then I have summation phi p equals 1 plus, now realize that this is also equal to A, right? It doesn't depend on how do you index them. It basically records at this price vector P, okay? At this price vector P, it records the summation of positive excess demands, okay? So these are the two things, the same things. Then what do you have? You have summation of updated prices times 1 plus A equals 1 plus A. So you have summation of the prices, updated prices, being equal to 1. And that's the second property. Okay? That's it. Now, for the third property, remember the third property was about the excess demand function. So if excess demand is positive, then updated price must be bigger than the original price. Okay? Now, I will not prove this property here, but I will put a PDF handout, okay, for this to Huzam and to my website. All right? So you can see the proof. That proof is a bit longer. It's not exactly very, I mean, it's not very difficult. It is still straightforward, but a bit longer. So I want you to go to that handout and look at the proof there. Okay, and I want you to understand the proof from the handout. Okay. So, do you have any questions about these properties? You there, right? You can hear me, right?
Yes.
Okay, you are not providing any input. I'm not exactly sure whether you are getting the material right. So you find no interesting comments or observations, or you do not have any questions then?
I have no question.
Okay, all right. So then let me go back to another issue, which is the existence theorem. Now here, we're going to build on Brouwer's fixed point theorem, okay? Basically, the idea is this. Now, the set S, remember the definition of it. Okay. Now, as you realize, this set is closed and bounded. Okay. In other words, it is compact. If phi function is continuous, okay, then according to the Brouwer's fixed point theorem, which we will not prove, we are not mathematicians, but we're going to use it. So if phi p ss is continuous, then there exists p star in S such that phi P star equals P star. Okay, so that is your existence theorem. Okay, so again, it depends on our definition of simplex, obviously, because we define the unit simplex as a closed and bounded set. So a continuous function that maps prices into prices in this compact set requires there is at least one P star, which is a fixed point. Fixed point in the sense that it doesn't change, right? I give you P star. The price updating mechanism gives me P star. That requires the continuity of phi. Okay, my friends. So that's your existence theorem. And that completes my discussion of, again, remember that we have positive properties of the Lavoisian equilibrium. One is existence. The other is uniqueness, and the third is stability. Now I completed my discussion on existence. Now I will discuss uniqueness, and next week we're going to discuss stability. Okay, then we're going to have normative properties of the Lavoisian equilibrium. Okay, we're gonna visit the first fundamental theorem of welfare economics and the second fundamental theorem of welfare economics. Okay. Either next week or possibly the week ahead. Okay, the 1 week from the next week. Okay, now I will discuss uniqueness. Okay. All right. So we have the model, right? We have demands. We have endowments. Okay. Now the parameters of this function, let's denote them by alpha. Okay. And endowments, these are the inputs of the model, right? Now, since endowments are fixed, I can also take them as parameters, okay? So basically, when I talk about P star, I'm talking about P of alpha, right? Because remember, in any economic model, solving that model means expressing the endogenous variables as functions of exogenous variables, okay, and structural parameters. So here we have some exogenous variables, endowments, okay, but they do not change. So I put everything together and the structural parameters of the demand function as well. So this becomes a parameter set. Okay. Now uniqueness means the function P alpha is unique. Okay. So in other words, if I give you the demand functions and the endowments, and if you find only one function, okay, under the price normalization, of course. So for a given normalization of prices, if you find only one function P alpha that solves your P star, then this equilibrium is unique. So imagine this. Imagine that alpha is just one-dimensional, okay? Alpha is just one-dimensional, and you have P alpha here, okay? Now, if you find something like this as the only solution, then it is unique, okay? Otherwise, you may have something like that, okay? So in that case, this is P1 alpha, this is P2 alpha. So for the same alpha, you find two different equilibrium prices, okay? This is P2 star, this is P1 star, okay? So in that case, not unique, okay? So that's the essential difference. All the inputs of the model for a given set of inputs, whether you find a unique P star or you can go different P stars. Careful, this is not the commodity, okay? This is not the number for commodity. This is the number for different equilibria. The first equilibrium, the second equilibrium, okay? But if you have only this, then it is unique, all right? That's the idea. Does it matter in practice? Well, sometimes it matters. Why? What you want to do is to study this, my friends. Comparative statics, right? The effect of alpha on P star. So this could be any parameter. It could be an endowment, it could be a parameter in the demand function, etc. That could be anything. And we are interested in that. More specifically, of course, you can choose a particular commodity, okay, and ask the particular parameter alpha k on Pi star, okay? Because you may imagine that alpha is multidimensional, right? Alpha 1, alpha 2, dot, 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 alpha k, dot, 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 alpha capital K. Okay? Now, if you have multiple equilibria, if equilibrium is not unique, plus if you change alpha, right? Because you are changing alpha here. That's a problem. How? How big is alpha? All right, let's say one of the solutions is that P1 alpha, okay? And the other solution is that P2 alpha. Now careful, all of these are equilibrium, okay? This is P1 star, this is P2 star, okay? And suppose that your alpha is here, okay? Now when you change alpha, Do you know where you are? You can be here in this equilibrium. You can be here in this equilibrium. Okay? And in the static models, it is still okay, not a big difference. But in dynamic models, it's a much bigger difference. There's much bigger issue because you are now changing alpha in time. Okay? That creates even bigger problems in dynamical models. Right? So it is very important, very important to understand whether your equilibrium is unique or not. In the literature, there are models that imply multiple equilibria, and there are models that imply unique equilibrium. All right? So that depends on the assumptions. That depends on the fundamentals of your economies. All right? Other than that, please just read the text. So they have further discussion about the empirics of these issues. But the idea is this. So I don't want you to be confused with the multiplicities here. Okay? There's one multiplicity in terms of prices, right? There are more than one price in the economy. But then, when you find the equilibrium, there is just one price vector, P star. Okay? Now, multiple equilibria means you can have P1 star, P2 star, P3 star, let's say, or you can denote it by letters. PA star, the first equilibrium, PB star as the second equilibrium, PC star as the third equilibrium. All right. So in that case, be careful. Let's say PA star is a price vector. PA1 star, PA2 star, PAN star. Okay? So again, these price vectors are defined for each and every commodity in the economy. Okay? So that's the idea behind uniqueness. All right? Now let me stop sharing. All right. So for today's lecture, that's all I'm going to share. So we completed our discussion of the Walras law, right? Then the Walrasian equilibrium. We defined it as the market clearing in all markets. Then we switch to the positive properties of the Walrasian equilibrium. We studied two of these. One is existence, the other is uniqueness. Okay. Next week, I will explain to you the stability of the Walrasian equilibrium. So we're gonna start studying some differential equations there to understand stability, because stability is a dynamic concept eventually. And in the meantime, you're gonna read the text, and then you're gonna check the proof on the website. Okay, the proof on the third necessary property of the Gale-Nikayuda mapping for it to be a correct price updating mechanism, because if excess demand is positive in a market, then updated price must be larger than the originally given price under the unit simplex, obviously. Okay. So that's it. That's it for today. If you have questions, comments, any input you want to provide, we have time. Otherwise, please check the website for any other updates, announcements, okay, other stuff. And I will see you next week if you have no input for now. In general, I am very, very dissatisfied, kind of disappointed with your silence and the attendance today. Where is the rest? Where is the rest of these people?
Hocam anlamaya çalışıyorum şahsen kendi adıma. O yüzden şimdilik sessizim.
So the rest of the people, and you start speaking in English. This is a course where the medium of instruction is 100% English. So just let the others know that yes, attendance is not mandatory, but strongly recommended. Okay? So if people think, okay, there is no mechanism that he can force us to be present. Yes, I cannot, but that would be reflected in your grade because you didn't get the material right, okay? Not because I will punish those who are not attending, but because just watching the video may not be enough. Okay? All right then. I will close this session and upload the videos and the handouts to Huzem without much ado, and see you next week on Wednesday morning, 9 a.m.
Thank you for the lesson. Have a nice day.
You have a nice day. Thank you very much.